Using power series for the exponential function and the cosine function, we can find a power series for their product by a fairly tedious multiplication process. We're told that the given function is analytic at a equals 0, which just means a power series representation exists centered at a equals 0. And we're going to multiply to find the first four non-zero terms of the Maclaurin series for the given function. Remember, a Maclaurin series is the power series centered at 0. Our function is e to the negative x times the cosine of x. E to the negative x has a power series representation of n equals the sum, as n goes from 0 to infinity, of negative x to the n divided by n factorial. And that equals 1 minus x plus 1/2 x squared minus 1 over 6x cubed, and so on. The cosine of x has a power series representation that looks like the sum as n goes from 0 to infinity of negative 1 to the n x to the 2n plus 1 over 2n plus 1 factorial. The terms look like 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial, and so on. For my purposes, no, you don't need to have these memorized. If ever this comes up, it would be in your homework and not a test for my class. And you can look them up as you need to. There's a table in our textbook. What we're looking for is e to the negative x times the cosine of x. Well, folks, that's going to look like 1 minus x plus 1/2 x squared minus 1/6 x cubed, and so on. I don't know how many terms we need. If we need more, we can generate them. That's for our e to the negative x times 1 minus 1/2 x squared plus 1 over 24 x to the 4th, and so on. And again, we can generate more terms if we need to. The thing that we're shooting for, though, is we want the first four non-zero terms of the Maclaurin series for the function. And we're going to do this just by good old-fashioned multiplication. 1 times 1 is 1. 1 times negative 1/2 x squared is negative 1/2 x squared. Then we have plus 1 over 24 x to the 4th. And I've exhausted all of the terms that I've written down multiplying by 1. So we're going to move on to multiplying by negative x. Negative x times 1 is negative x. Negative x times negative 1/2 x squared is a positive 1/2 x cubed. And negative x times 1/24 x to the 4th is minus 1 over 24 x to the 5th. Let's keep going with this process and see where it leads us. 1/2 x squared times 1 is going to give us a 1/2 x squared, and I'm lining that up with the previously existing x squared term. 1/2 x squared times negative 1/2 x squared is going to be a negative 1/4 x to the 4th. Again, I'm lining that up with the x to the 4th term. And then 1/2 x squared times 1/24 x to the 4th is plus 1 over 48 x to the 6th. I suppose I should put a plus in front of that 1/2 x squared as well. Negative 1/6 x cubed times 1 is negative 1/6 x cubed. That times negative 1/2 x squared is going to give us a positive 1/12 x to the 5th. And just to finish it off, negative 1/6 times 1/24 is going to be negative 1 over 96, and then the x cubed times x fourth gives us x to the 7th. If we start collecting like terms here, that would be just adding down the columns for the appropriate powers of x. We have 1 minus x, but wait a minute, the x squared term zeroes out. Moving on, we have 1/2 x cubed times negative 1/6 x cubed. That's going to give us 1/3 x cubed. But I had maybe thought that we'd only need up to x cubed, because remember, we're looking for the first four non-zero terms. Now I see, since the x squared is subtracted out, we need the x to the fourth term. And there's an additional x to the fourth that we didn't write down because the 1 from the cosine expression still needs to multiply the next term from the exponential expression. And the next term is 1 over 4 factorial x to the fourth. So I need to include 1 over 24x to the fourth in our sum of the first 4 terms. I mean, how do you know you need to do this? I don't know. You write down a bunch of terms and then you see where things land, and then you make sure you've collected all of the particular power that you're working on. That gives us an additional term, 1/6x to the fourth, negative 1/6x to the fourth. So we're going to say here that the power series for e to the negative x cosine of x is equal to 1 minus x plus 1/3 x cubed minus 1/6 x to the fourth plus ... This process will show up somewhere later in the chapter, but I encourage you to practice it a few times just so you have an idea of what it looks like. And really, this is an exercise in bookkeeping.